Hello everyone, very good evening. I hope you all are good. So let's start with today's topic, or let's discuss what we are going to read. So yesterday in the class, we did questions from KVL and KCL, and after that we studied two things. One is your Wheatstone bridge, and another was your meter bridge. Okay. So first I will take you through what is this Wheatstone bridge. I told you it will have four registers. Okay. So one register was like this, another was this, another this, another this. So it was looking something like this. Let's say this is R1, this is R2, this is R3, this is R4. And then one diagonal ends will be connected to the battery. Okay? And then here galvanometer will be connected. This was your this structure is called your what? This particular structure is called what? Wheatstone bridge. So this is your Wheatstone bridge. Now the question is, this Wheatstone bridge, I mean, why we are having it in first place? Okay. So why we are having it? In order to calculate unknown resistance. Let's say we don't know the value of R3, but we know the value of R1, R2, and R4. Okay. So suppose we are having three known registers. In the laboratory, you have three known registers, and there is one register which resistance is not known. In that case, you can use Wheatstone bridge to calculate the value of R3. But when we will be able to calculate the value of R3 with the help of Wheatstone bridge? Only if the Wheatstone bridge is what? In balanced condition. So what is this balanced Wheatstone bridge? Just say if the Wheatstone bridge is not balanced, let's talk about this. It is not balanced. So when it is not balanced, what it will look like? Current distribution will look like this. Let's say here current I is coming. Here current I1 will go. And let's say here it is coming as I2. So I got divided into two parts at junction A, I1 and I2. Now this I1 will reach here at point C. And at point C, I1 is getting divided into two parts. Let's say here it is coming as IG. And then how much current will go this side? Let's say total current coming here was I1. Then IG is going this side. Then here how much current will come? I1 minus IG. Okay. So this is this. Now at this end, what will happen? Here coming current is IG and here coming current is I2. So this side, how much current will go? I2 plus IG. And finally, here you will get current equal to how much? I1 plus I2, that is I. So this is how current will get distributed if Wheatstone bridge is not balanced. Which is Wheatstone bridge not balanced means current through the galvanometer arm is not zero. So IG is not zero. In that case, current distribution will look like this. In the case where your Wheatstone bridge is balanced, in that case, IG is equal to zero. So let's talk about that case. So let's draw it again. This was your R1, this is your R2, and this is your what? R3, and this is your R4. Done it? And then there was this battery. It is like this. Now let's say this Wheatstone bridge is balanced. In that case, what will happen? No current will flow through the galvanometer arm. So basically, if no current is flowing through the galvanometer arm, what is the meaning of it? Potential of this point and this point is becoming same. That is why no current is flowing through this. So there is no current through this thing. Then we will say this is balanced condition. Done. And in balanced condition, we will get certain relation between R1, R2, R3, and R4. Let's talk about it. You can calculate it by using what? KVL. I have told you to do it. I don't know how many of you did it, but let me show you here. Let's say here I current is coming. Now this side I1 will go. This side I2 will go. At this point, let's call it point P. At point P, current division will not occur because through galvanometer arm, no current is going. इसका मतलब क्या है? इधर का सारा current इधर आ जाएगा. And similarly, at this point Q, Again, no current coming from anywhere, so I2 will go this side. Everyone agree with this current distribution? Everyone agree with this current distribution? Okay, it must be Kiran. Okay, Mahesh. ठीक है. Okay, Kiran. ठीक है. डन है. चलो ठीक है, यानी कि सभी को क्लियर है. If everyone is clear with this, then let's move ahead with the KVL. Now apply KVL in the loop. Let's say this is point A and this is point B and this is C and this is D. So let's apply first KVL in A, P. I mean, in which you feel like calculating KVL? बताओ कैसे करूं? Any idea anyone can give? Then I will go that way. एक काम करो, केवीएल लिखो आप. ए बी, ए पी बी क्यू ए पी बी क्यू ए. दैट वे यू वांट मी टू डू. लेकिन I1 I2 डिफरेंट आएगा, तो आप R1 R2 में रिलेशन नहीं निकाल पाओगे. Is it okay? If you're telling, I will write that. चलो लिखते हैं. If we do that, what you will write in this loop? A P B Q A. Somebody said me this. Let's write it. So minus I1 R1. Now I'm assuming you know how to write KVL. So I'm not going to. I'm just simply moving along this along the current direction. Minus I1 R1. Minus I1 R2 and plus I2 R4 plus how much? I2 R3. This is equal to 0. So from here, if you look, this is going to be equal to how much? I1 R1 plus R2 is equal to I2 R3 plus R4. This is what we are going to get. How we will get relationship between R1, R2, R3 and R4? एक काम करो, करंट का वैल्यू भी आप निकाल सकते हो. आई का, जैसे तुम लोगों को मैंने एक चीज बताया था कि करंट डिस्ट्रीब्यूशन हम कैसे करते हैं. टू थिंग्स आर इन पैरेलल. I mean, again, that you have to again do the KVL. So यहाँ पे you should have done it actually. I gave you the homework. That is why. क्योंकि यहाँ पे बहुत सारी क्वेश्चंस लिखने पड़ेंगे. ठीक है. So if I move from, if I calculate current, this R1 and R2 are in series. This R3 and R4 are in what? They are in what? Series. ठीक है. So R equivalent क्या है? R1 plus R2 in series. This in series is in parallel with R1 and R2 and this is R3 plus R4. It is like this. ठीक है. डन है. अगर यहाँ पे मैं एक चीज और बोलूं, लेट्स से I1 एंड I2 यहाँ पे इक्वल कब होगा? अब मुझे आप बताओ, ये I1 और I2 इक्वल कब होगा? एनीवन, एनी आइडिया? I1 I2 इक्वल कब होगा? यस. ओके, अगेन आई विल गिव दिस यू एज अ होमवर्क. तुम लोगों ने कुछ किया नहीं, मैंने बोला था करके आने के लिए इसको. मैंने बोला था केवीएल अप्लाई करना है एंड यू हैव टू लेट मी नो. यस महेश, व्हेन द रेजिस्टेंसेस आर सेम. डन है. व्हेन R1 plus R2 is same as R3 plus R4. I want you to do one thing here. If anyone can do, please do it. How you will calculate here relationship between R1, R2, R3, R4. So I'm giving you time to think over it. Please think over it and let me know. Okay, this way things won't work. You need to do it. Yes, Kiran. Just try to think. Look at the diagram. Try to think कैसे same आएगा. Take your time to it. Everybody. So that way you will get to practice your KVL also. So try calculating relationships. Yes, everybody try it. ठीक है. Yes, we thought of doing something. What we can do easily to get this? How we should be going around it? Let me know, everybody. I told you in the case of balanced Wheatstone bridge, P and Q will have same potential. Can you calculate Vp minus Vq in two different ways to get things done? Okay, chalo. I'm just I will do it afresh. Okay. This was galvanometer arm. Then this was another register. This was this. This is another. This is another. Okay. It was like this. This is P and this is Q. In the case of balanced condition, there is no current here. So Vp, potential at P is equal to potential at Q. Okay. This is for sure, right? Now here you have taken a battery which is distributing the current. I have taken here current distribution. Let's say its potential difference is V. Same way we did. I1 we distributed here, I2 here. Since no current through this, here I1 will come and here I2 will go. This is R1, this is R2, this is R3 and this is R4. Now you already know one thing, Vp and VQ have the same potential. So Vp minus VQ is 0. Can we do one thing? We can start writing KVL. हमेशा KVL क्लोज लूप में नहीं लिख सकते, स्ट्रेट लूप में भी लिख सकते हैं, हाफ लूप में भी लिख सकते हैं. So let's start moving from point P and reach to point Q. So we can either reach to point Q this way or either we can reach to point Q this way. So both way we can try. Let's talk about moving this way. So Vp minus सॉरी करंट के डायरेक्शन के ऑपोजिट चल रहे हो, व्हाट यू विल राइट प्लस I1 R1. ठीक है, यहाँ पे क्या लिखोगे प्लस I1 R1 and this way what you are going to write, you are moving in the direction of current, so minus I2 R2 and you are reaching at point Q. Here we have to stop, so equal to sign दे दो VQ. This is how also we can write KVL if not in the closed loop, क्योंकि if in the closed loop equal to VP करते हैं हम. ठीक है, here we are not writing in the closed loop, we are simply starting from P and reaching at Q. So up start from the P, Vp, whatever elements you are getting, write the potential changes, then equate it to VQ. And you already know Vp minus VQ is equal to 0. So basically, from here you are getting I1 R1 is equal to I2 R2. This is the one thing you got. Okay. Similarly, write this KVL this way. If you are going to write it this way, P to Q, again move from P to Q. So VP से आप बढ़ना start करो, VP minus I1 R4, and this way what you are going to write plus I2 R3, and this is equal to how much? Again VQ. This way we can write. We can move from P to Q like this. Now Vp minus VQ is 0. So here you are getting what? I1 R4 is equal to I2 R3. This is equation 2. Now divide equation 1 by equation 2. If you're going to divide it, what you will get? I1 R1 divided by, चलो next slide में करती हूँ. So what you will write? First equation तुम्हारा क्या है? First equation is I1 R1. I1 R1 is equal to I2 R2. सेकेंड इक्वेशन क्या है? I1 R3 is equal to I2 R4. Divide it. I1 will get cancelled. I2 will get cancelled. And here you will get R1 by R3 is equal to R2 by R4. So this is the condition of balanced Wheatstone bridge. The one I discussed yesterday. Okay. So in the case of balanced Wheatstone bridge, what is the relation you are going to get? This R1 by R2, R1 by R2 will be equal to how much? R4 by R3 ऐसे भी लिख सकते हैं ना, क्योंकि देखो यहाँ पे क्या आया, R1 by R3, इस R2 को इधर ले जाओ, R3 को इधर ले जाओ, ऐसे भी लिख सकते हैं ना। R1 by R2 is equal to R3 by R4। डन है? क्लियर है सबको? यस किरण। R1 by R4 कैसे आ रहा है तुम्हारा? R1 इंटू R4 जा रहा है किरण। R2 by R3 कैसे आ रहा है? R1 by R4 नहीं आएगा। ओके, या दैट वी कैन ऑल्सो राइट। एक सेकेंड, मैंने क्या लिखा यहाँ पे? R1 by R3। सो दिस R1 by this R3। ओके, मैंने तो ऑपोजिट लिख दिया। ओके ओके ओके, थैंक यू फॉर रिमाइंडिंग। यहाँ पे मैंने इक्वेशन को गलत लिख दिया, जो इक्वेशन आया है उसको डायरेक्टली लिखो, सॉरी। इक्वेशन गलत लिखा है शायद, चेक कर लो। I1 R1 इज इक्वल टू I2 R2, I1 R1 इज इक्वल टू I2 R2, एंड I1 R4 था ना, मैंने I1 R3 लिख दिया है, इसलिए गलती हो रहा है यहाँ पे। एक सेकेंड। यस, थैंक यू किरण। सॉरी, आई डिड द मिस्टेक राइट इन राइटिंग थिंग्स। I1 R4 था, I2 R3 था। सो यू विल गेट हियर व्हाट? R1 by R4 is equal to R2 by R3. This is correct, right? And this can also be written as R1 by R2, है ना? इसको इधर शिफ्ट कर दो, इसको इधर शिफ्ट कर दो, क्रॉस मल्टीप्लाई वन साइडेड। R2 को इधर ले आओ, R4 को उधर ले जाओ, so you can write R1 by R2 is equal to R4 by R3. Okay, am I correct in writing this? Yes. R1 by R2, R4 by R3, or you do R1 by R4, R2 by R3. So balanced Wheatstone bridge will look like this. अगर ये balanced है, then let's call this register 1, register 2, 3, 4. So either register 1 divided by register 3 is equal to register 2 divided by register 4. Either you take ratio this way or you can take ratio this way. R1 by R2 will be equal to R3 by R4. ठीक है? This way you can do. Then this is how we solve it basically. So this is called your balanced Wheatstone bridge, when ratio of registers on one side is equal to ratio of registers on the other side. Either you take side horizontally or vertically. Either ऐसे ratio लो दोनों side का, या फिर दोनों side का ऐसे ratio ले लो. Whatever way you take it, you will get the same answer. ठीक है? So this is your balanced Wheatstone bridge. I hope you have got it. Then we studied what meter bridge. कल मैंने ये भी discuss किया था. So meter bridge में मैंने बोला this is nothing but your balanced Wheatstone bridge, right? Here in place of 4 registers, we are simply taking 2 registers. One register is your known, so one is known, and here only one is R is unknown actually. S indicates a standard resistance, and a standard resistance stands for something that is known. So this is your known and this is your unknown. So in case of balanced Wheatstone bridge that we studied before, we required 3 known registers to calculate 1 unknown register, right? In case of meter bridge, we only require 1 known register in order to calculate unknown resistance. Okay? So in this case, we are replacing other 2 registers with a long wire. Here there is a long wire, as I told you yesterday. ठीक है? क्या होगा? यहाँ पे एक 1 meter long wire है. So basically we have this small line जो तुम्हें दिख रहा है ना. This is a small wire of length 1 meter. It will have certain area of cross section. And what we are doing here, then we are taking a galvanometer this is called jockey, basically a brush that you can slide on the wire. You will slide it to get a point called null point. Null point meaning the point where if this brush touches, then there won't be current in the galvanometer arm, and hence that case will look like a case of balanced Wheatstone bridge. क्योंकि अगर आप वैसे निकालते हो ना, it will look like what? R को आप ऐसे लिख डालो R, S को आप ऐसे लिख डालो S, ठीक है? Let's say here you are getting null point. So this length of wire will have certain resistance. How much? If L1 length पे मिला है तो rho L1 by A, and what will be the resistance of this? That will be rho into 100 minus L1 by A. A will remain same because whole the wire is, I mean, same. So they have same area of cross section. Length is 1 meter. Balance point we measure from the left hand side, I have told you. So from here we measure the balance point with the help of meter scale. So we got this length as L1. So rest of the length will become 100 minus L1. So L1 length will have resistance of rho L1 by A, and this will have a resistance of rho into 100 minus L1 by A. Then you again draw it like this. This is rho L1 by A, and then this is how much? Rho 100 minus L1 by A. And this was your which point? A, this point A, and this is your point B, and this is your point C, and then this was your D point, so this is your D point. This was your galvanometer, okay? It touched the wire at D point, dividing wire into two regions of length L1 and 100 minus L1. And then this whole, it was connected to what? A battery. Battery is responsible for sending out current, right? So we need to have a battery. Now, in case of no current through the galvanometer, that is the case here, what you will write now, R by, you will simply write R by rho L1 by A is equal to S divided by rho 100 minus L1 by A. You will take, you will equate their ratios, right? R by this equal to S by this. So if you do that, you can clearly see here, this will get cancelled and R by S will become equal to how much? L1 by 100 minus L1. So this you can use to calculate the value of R. If you know, because if you know L1, and L1 you can measure in the experiment hall with the help of meter scale, right? So this way we can do it. This is meter bridge and galvanometer. I hope you people have understood it. Anyone having any doubts so far in any of this? Then let me know. No? Then we will move on with ammeter and voltmeter. They are very important. We will deal with that. Which point to explain, Lakshmi, once more? Whole thing or what? You can unmute yourself and you can tell me what is that one point which is bothering you. I mean, क्या है जो नहीं समझ में आ रहा है? That I need to know. ठीक है, क्योंकि yesterday also I explained it, today also I'm explaining. If you are getting problem, it means कि कोई ऐसा point है जो आप समझ नहीं पा रहे हो. So you should clearly tell to me कि what is problematic here, क्या trouble कर रहा है. देखो फॉर्मूले में तो मैंने ये बोला ना कि अच्छा लक्ष्मी एक चीज बताओ, इज इट लुकिंग लाइक अ व्हीटस्टोन ब्रिज और नॉट? अगर वहां प्रॉब्लम है तो आई कैन टेल यू, इज इट लुकिंग लाइक अ व्हीटस्टोन ब्रिज और नॉट?
Yes, ma'am.
दिख रहा है ना? सो in the case you are getting a null point at point D, it means there is no current through the galvanometer. Then this is a balanced Wheatstone bridge or not?
Yes, ma'am.
Yes, it is balanced. And in case of balanced Wheatstone bridge, just now we studied thing. What we studied? We studied that R1 by R2 will be equal to R4 by R3. So if you are having a balanced Wheatstone bridge, something like this, if you have something like this, if this is a balanced Wheatstone bridge, okay? Let's say this is R1, this is R2, this is R3, this is R4. So what you can say, if this is a balanced Wheatstone bridge, हमने equation पढ़ा ना, R1 by R2 को हम लिख सकते हैं R3 by R4. Here R1 is equal to R. आप देख लो यहाँ पे R1 R के बराबर है, R2 S के बराबर है. If you talk about sorry, R3 S के बराबर है, and R2 and R4 की अगर आप बात करो तो R3 is this, R4 is this. From where I am doing this? Resistance का फॉर्मूला मैंने आप लोगों को बताया है लेंथ के टर्म में. What is the formula of resistance? Rho L by A. So if this length is L1, this resistance will be rho L1 by A, and another one will be rho L2 by A. ठीक है, L2 is 100 minus L1. So basically I did R1 by this by this, by the concept of balanced Wheatstone bridge, and that is why I've written this. Okay, Lakshmi, ठीक है, thank you. Please everyone read more, ठीक है. होमवर्क की तरह चीजों को, कॉन्सेप्ट को पढ़ा करो. आफ्टर द क्लास इज ओवर. व्हाट इज दिस गैल्वेनोमीटर? We will read this galvanometer in magnetism. So for now, I will just tell you one thing. This is a device which measures current. ठीक है? So it has basically a scale sort of thing, and then there are markings here. ठीक है? And initially when there is no current, जैसे तुमने स्केल देखा है ना, स्केल होता है, right? Let's delete all this thing. So this is basically कुछ ऐसा सर्कुलर दिखेगा. ठीक है, यहाँ पे मार्किंग्स होते हैं 1 2 3 4 5 6 करके, अप टू 180 हो सकता है, डिपेंड्स ऑन द गैल्वेनोमीटर, उससे हमें मतलब नहीं है. और यहाँ पे एक पॉइंटर होगा that will mark at the zero mark. ठीक है, that will lie at the zero mark. And when current will flow through this galvanometer, suppose you are connecting it with the battery, if current will flow through it, then what will happen? Because of current flow, this scale will rotate. ठीक है, अगर इतना करंट फ्लो किया है, that can rotate this scale up to this value, then this will rotate by 100%. I mean, it will move from zero mark to the maximum mark if sufficient current is there. That sufficient current is called galvanometer current. That gets indicated by IG. So IG हम कहते हैं इसको, this is full deflection current. Full deflection current कहने का मतलब current which is capable of bringing out full deflection inside the galvanometer. So full deflection current. But when not sufficient current is there, let's say this current I that is flowing through the galvanometer, I is less than IG, then full deflection will not occur. Maybe your scale will remain somewhere here. And accordingly, it will tell how much current is flowing through the galvanometer. So this is basically an instrument used to, yes, Kiran, galvanometer is just like a meter, but we modify galvanometer to become a meter. ठीक है, so a meter is not galvanometer. Yes, galvanometer is there, but we do certain modification that I will tell you. अभी मैंने बोला plain galvanometer क्या है? Will measure current. And full deflection current is what? Current that will move the scale from zero mark to maximum mark. So that is full deflection current. If current is less than full deflection current, this scale will go to some other mark, not to the 100 वाला mark. ठीक है, complete mark पे नहीं जाएगा. This is what you need to remember. Now let's say we are using galvanometer to measure current. Let's talk about this circuit. ठीक है, what is this circuit? This circuit has a battery E. It has a resistance R. How much current is there? Current is there E by R. We don't know the value of E. We don't know the value of R, and we need to measure I. So if we don't know E and R, we cannot do calculation and calculate I. We can only use instrument in order to measure I. So now what we are going to do is we are going to use the instrument. So we are going to connect galvanometer in series with the resistor. Why in series? Because you are going to measure current flowing through R. We have to measure current flowing through R. So we need to connect device in series with R. Then only same current will go through device also. है ना? If you want to measure current through R, then you need to connect device in series. Why in series? Because in series only same current will flow, and we need to measure current flowing through R. So that is why galvanometer we are connecting in series. But now the question is, will galvanometer measure the value I, or will it measure some different value? Yes, it will measure some different value क्योंकि the moment you are connecting galvanometer in the circuit, current is changing because of the device. This device has some resistance, है ना? This is made of something. So overall, इस circuit का अगर आप resistance निकालो, this value is R plus RG. This value is how much? R plus RG. So now current flowing through the circuit will become how much? E by R plus RG. ठीक है? So our purpose was to calculate E by R, but when we will connect galvanometer in the circuit like this, we are going to measure E by R plus RG. So this is a wrong measurement. Done it? I mean, this galvanometer won't give me the correct reading. There is mistake happening. Why mistake is happening? Because of the resistance of this device. Done it? And if we want to measure E by R, we need to make RG 0. RG tends to 0. RG almost equal to 0. Okay? So we need to minimize RG. How we can minimize RG? And that is why it is said that we cannot directly use galvanometer as a we cannot directly use galvanometer to measure current in the circuit. Why? Because the moment we connect galvanometer in series with the resistance through whatever we want to calculate current, that galvanometer is going to change the current of the circuit. And if current of the circuit is changing, what will happen? It is giving us false measurement. So we need to do something, right? Everyone agree? किसी को भी डाउट है ये चीज समझने में कि गैल्वेनोमीटर विल गिव अस फॉल्स रीडिंग, नॉट द ट्रू रीडिंग. ट्रू रीडिंग इज व्हाट हियर E by R we want to measure and we are getting E by R plus RG. agree? चलो ठीक है. अगर किसी को डाउट नहीं है देन आई विल मूव अहेड एंड आई एम गोइंग टू नाउ रिड्यूस RG. हमारा टास्क क्या है? RG को 0 करना. नाउ you should have one thing in your mind. When you connect two resistors, let's say this is R1, this is R2. When you connect two resistors in series, then R equivalent is greater than R1 and R equivalent is greater than R2. ठीक है? क्योंकि let's say R1 is 2 and R2 is 3. Then 3 plus 2 is 5. So 5 is greater than 2, 5 is greater than 3. So in series, R equivalent is always greater than individual resistors. This is for sure. ठीक है? And in parallel, when you connect two resistors in, let's draw it. When we connect two resistors in parallel, let's say this is R1, this is R2, then R equivalent जो होगा ना, that will be less than R2 and R equivalent will be less than R2. So in case of series, R equivalent is greater than individual resistors, and in case of parallel, R equivalent is less than individual resistors. This is the case. Okay? So here what we have to do, we have to make RG 0, make RG very small, very, very small. So what we will do one thing, we will connect a small resistor. Let's say this is called shunt resistor. Since this is very small, the value of resistance of AC is very small, and that is why it is called shunt resistance. So what we are doing is we are connecting shunt resistance in parallel with the galvanometer. So this has a resistance of RG, this has a resistance of S. Now, if we are going to connect this in order to calculate current, then what will happen? Its R equivalent will be what? Its R equivalent will be less than RG. And its R equivalent will be less than S. And S is already very, very small. R equivalent is becoming more smaller. So overall, if we are able to connect a very small resistance in parallel with the galvanometer, that galvanometer is called ammeter. इसी को हम क्या बुलाते हैं? Ammeter बुलाते हैं. So ammeter is this. When we connect a shunt resistance in parallel with the galvanometer, we get ammeter. Okay? This is called ammeter and it is used to measure current. Now, if you're connecting this ammeter into the circuit, its R equivalent is very small. So, मैंने जो यहाँ बताया था आपको, current क्या है? E by R है. Now, if you're connecting here ammeter, then current will be how much? E by R plus R equivalent. And that R equivalent is very, very small. So, that is not going to change the value of current much. very negligible change will occur, and hence we will say that we are almost able to measure the right value of current. So ammeter को हम ये वाले इसको अब हम कनेक्ट करेंगे here in series with resistor, and इसी को हम क्या बुला रहे हैं, ammeter. So now we are connecting ammeter here. So this is called ammeter. What is ammeter? How we convert galvanometer to ammeter? By connecting a shunt resistance in parallel with the what? In parallel with the galvanometer. Anyone has any conceptual doubt here? Then let me know. किसी को डाउट है तो बताओ. नो, ठीक है. किरण, लक्ष्मी, anyone else? श्रव्या, वेनु, संजना, महेश, लतिका, क्षेत्रा, किरण, किरण तो बोला, कार्तिक, ध्रुव, अभी, ओके ओके, किसी को डाउट नहीं है, चलो ठीक है. सो दिस इज योर अमीटर. ठीक है, अब देखो अमीटर कैसा दिखता है तुम्हें पता है ना. अमीटर इज दिस. नाउ वी विल टॉक अबाउट, जैसे क्वेश्चंस जब तुम्हें मिलेगा ना, तो एक क्वेश्चन होता है, यू विल डू द सच क्वेश्चंस, रेंज ऑफ अमीटर. रेंज ऑफ अमीटर का मतलब क्या होता है? I mean, if it is given that range of ammeter is 3 ampere, it means what? It means it can measure current up to 3 ampere. ठीक है? So across it 3 ampere of current can enter. So this is called range of ammeter. उसके बाद मैंने बोला था एक और करंट का कॉन्सेप्ट बोला था, फुल डिफ्लेक्शन करंट. फुल डिफ्लेक्शन करंट किसको बोलते हो? IG. ठीक है? And that also will be given in the question. Maybe it's given. So let's say this is some milliampere, some 2 milliampere or something. So अगर अगर क्वेश्चन में ऐसा दिया ना, रेंज ऑफ अमीटर इज 3 एम्पियर, मींस 3 एम्पियर करंट विल एंटर. Full deflection current is 2 milliampere, means up to this maximum current that can go is IG. So 3 is coming here total. IG is going this way. This way how much current will go? This way current going will be range of ammeter, that is I. इसको I मैं बुला रही हूँ अभी, I minus IG, है ना? Because at this point P, current is getting divided into two branch, one across galvanometer. Galvanometer के through maximum current that can go is IG, and the rest current will go through the shunt, so I minus IG. ठीक है? So these are the concepts: range of ammeter, full deflection current, and what is the equation that you can write in ammeter. So in case of ammeter, this shunt and this galvanometer that is having resistance RG, these two are in parallel, है ना? ये दोनों क्या है? पैरेलल में है. So whatever is the voltage drop across S, same will be the voltage drop across G. So what is voltage drop across S? क्या होगा? Current into resistance, so that is I minus IG into S. ठीक है? That is your how much? I minus IG into S. And what is the voltage drop across galvanometer? Current through galvanometer into resistance of galvanometer, and these two will be equal. यही है तुम्हारा इक्वेशन ऑफ अमीटर. अगर कहीं भी क्वेश्चन आता है, क्वेश्चन में ये दिया रहेगा, रेंज ऑफ अमीटर इज दिस, full deflection current is this, calculate the value of shunt. So you can simply put in this equation, you can get the answer. But rather than mugging up the formulas, you should know the concept. Concept क्या है? ठीक है? Anyone any doubt here? If yes, you can let me know. Then Kiran, it won't be able to measure the current. ठीक है? It will only measure up to 3 ampere. So we need to attach a ammeter whose range is closer to the range of current available in the circuit. ठीक है? So basically ये dysfunctional हो जाएगा, that won't work. Purpose serve नहीं होगा. ठीक है? कोई blast नहीं होगा, but yes, that won't be able to measure it. Anyone else? Any doubt? If you have, then you can let me know. करंट इज लेस देन 3 एम्पियर, देन रेंज इतना है ना, तो जो भी लेस वैल्यू है उसी लेस वैल्यू को आप लोगे यहाँ पे। ठीक है, डन। उसमें कोई दिक्कत नहीं होगी। इफ रेंज इज ऑफ अप टू 3 एम्पियर, सपोज कर लो रेंज दिया हुआ है 0 से 3 एम्पियर तक, and you are measuring 2 ampere current, so here 2 ampere current will come in that case, done है। And if Ig is of the range of milliampere, then definitely here milliampere will go, done है, because 2 ampere current is coming, done है। So when you will get the question, you will get more clarity. So you should be practicing question of ammeter and voltmeter from previous year JEE mains or NEET examination. Please practice करना तुम लोग। So converting galvanometer to ammeter will look like this. This is your what? Ammeter. ठीक है? How we convert galvanometer to ammeter? By connecting shunt in parallel with this. Shunt means S का मतलब क्या होता है? Very small resistance. Okay. Now we will talk about voltmeter. Voltmeter is what? Okay. Anyone sent me anything? Resistance? No. If you have constructed a meter, I mean you have already made its resistance small, so that external factor is not going to affect the resistance of ammeter. ठीक है? Resistance of ammeter will be because of what? Because of its internal construction, है ना। ये देखो यहाँ पे जो अमीटर है इसका रेजिस्टेंस किस चीज पे डिपेंड करेगा? आरजी कितना है, एस कितना है। इन दोनों के पैरेलल का जो भी आर इक्विवेलेंट होगा, दैट वोंट डिपेंड ऑन हाउ मच करंट इज फ्लोइंग थ्रू द सर्किट। उस पर डिपेंड नहीं करेगा ना, करंट पे रेजिस्टेंस नहीं डिपेंड करता। दैट इज द फंक्शन ऑफ इंटरनल स्ट्रक्चर, मटेरियल का प्रॉपर्टी, एरिया ऑफ क्रॉस सेक्शन। सो बेसिकली एस एंड आरजी के वैल्यू पे डिपेंड करेगा। ठीक है किरण? ओके, नाउ वी विल टॉक अबाउट वोल्ट मीटर। वोल्ट मीटर क्या है? वोल्ट मीटर तुम्हारा इट विल मेजर वोल्टेज, सो वी कैन यूज वोल्ट गैल्वेनोमीटर ऑल्सो टू मेजर वोल्टेज। ठीक है, सो वोल्ट मीटर का मतलब क्या है? व्हाट इट विल डू? इट विल मेजर वोल्टेज। Now let's say what we want to do is we want to measure voltage across R2। R2 के क्रॉस हम क्या करना चाहते हैं? वोल्टेज को मेजर करना चाहते हैं। सो इन दिस सर्किट इफ यू कैलकुलेट करंट का वैल्यू, इट इज इक्वल टू हाउ मच? E बाई R1 प्लस R2, है ना। सो दिस इज द वैल्यू ऑफ करंट। व्हाट इज वोल्टेज ड्रॉप अक्रॉस R2? R2 के क्रॉस वोल्टेज क्या होगा? सो वोल्टेज दैट वी वांट टू मेजर, दैट इज वोल्टेज अक्रॉस R2 is equal to IR2, right? So IR2 you want to measure, that is ER2 by R1 plus R2 you want to measure. Now what we did it, what I did is I connected a galvanometer in parallel with R2, क्योंकि if you have to measure voltage across anything, you need to connect device in parallel, because in parallel only voltage will be same. जैसे करंट को मेजर करने के लिए हमने अमीटर को कैसे लगाया? सीरीज में लगाया। we were measuring what? Current through R. We were measuring current through R. So we connected ammeter in series with R. Then only same current will flow through the ammeter. Now let's say we are going to calculate voltage drop across R. So voltage drop अगर आप R के क्रॉस लगा रहे हो, तो वोल्ट मीटर को मुझे कैसे जोड़ना होगा? पैरेलल में। देन ओनली वी विल से व्हाटएवर इज द वोल्टेज ड्रॉप or difference, potential difference across voltmeter, that is same as potential difference across R. So then voltmeter reading will be equal to potential difference across R. So we need to connect device in parallel if that device purpose is to measure voltage difference. ठीक है, so here across R2 we are going to measure potential difference, इसीलिए मैंने गैल्वेनोमीटर को कनेक्ट किया across R2। गैल्वेनोमीटर को कैसे कनेक्ट किया? अक्रॉस R2 पैरेलल में। ठीक है, अब देखो ऐसे गैल्वेनोमीटर को कनेक्ट करने से कुछ प्रॉब्लम हो रहा है क्या? वोल्टेज, ये वाला वोल्टेज मेजर कर पाएगा क्या? यानी कि IR2 मेजर कर पा रहा है क्या? सो I करंट तो ऐसे फ्लो किया, ठीक है, यहाँ पे देखो आई करंट आया, ठीक है, यहाँ पे आई करंट आया. नाउ आई विल गेट डिवाइडेड. सो हियर सम करंट I1 and here some current I2. So what is the potential difference across I2 R2 now? That is I1 R2. That is how much? I1 R2, and which is less than that of IR2, है ना, क्योंकि I1 is definitely less than I. Done है? I1 is what? It is less than I, right? So I1 R2 it is going to measure. Less value measure करके देगा. So there is a problem. We need to fix it. How we can fix it? So it can only be fixed if I1 को हम लोग I के बराबर करना चाहें. ठीक है, and that is only possible if we make I2 tends to 0. I2 0 कब होगा? करंट किस साइड नहीं जाता है? अब बताओ तुम लोग, मुझे आइडिया दो. I2 को हम 0 कैसे कर सकते हैं? लेट मी नो हाउ वी कैन मेक इट 0. यस, एनीबॉडी? यस किरण, इंसुलेटर होगा तो करंट नहीं जाएगा. वेरी गुड. सो इफ देयर इज अ इंसुलेटर दिस साइड, इंसुलेटर कहने का मतलब क्या है? हाई रेजिस्टेंस. इंसुलेटर मतलब क्या होगा? हाई वैल्यू ऑफ रेजिस्टेंस. एंड हाई वैल्यू ऑफ रेजिस्टेंस हम कैसे कर सकते हैं? जी का रेजिस्टेंस तो आर जी है. सो we can change, we can try to change the resistance of galvanometer so that its resistance become very high. So in order to convert galvanometer into voltmeter, what we do is we connect a very high resistance in series with galvanometer. So if we are connecting this like this, क्या होगा बताओ? Yes, किरण, very good. So यहाँ पे R equivalent क्या हो जाएगा? R plus RG plus RH, डन है, विच इज फार फार ग्रेटर देन RG, है ना, क्योंकि RH is very high. With very high thing you are adding a small thing that is becoming very high already. ठीक है, so all of sudden when you are converting galvanometer to voltmeter, let me change it, this is voltmeter. ठीक है, टैग सेम रह गया है. So here, this will act as what? High resistance thing, and this we called as a voltmeter. Now, what this voltmeter will do? अब आप ध्यान से देखो, अगर मैंने यहाँ पे सेम सर्किट को रिपीट किया, this was R1, this is R2, and across this I'm connecting this galvanometer having high resistance connected in series like this, and this is connected to the battery. So whatever current is coming out, here I current is coming. So this current will get divided into two parts, this part and this part. If this upper part has a very high resistance, so very small current will go this side, very small, of the range of microampere, let's say. So बहुत ही छोटा current जा रहा है. Maximum current will go this side. ठीक है, so almost I current will go through R2, and in that case we will say that potential difference across R2, that is I2 R2, is almost tending to be IR2, and hence the potential that this voltmeter is measuring is equal to I2 R2, so that is equal to IR. Done it? So how we construct a voltmeter? By connecting a very high resistance value with the galvanometer. So अगर यहाँ पे मैं फिर से दिखाऊं तुम्हें, R1 है and this is your R2. If we are connecting voltmeter को ऐसे indicate करते हैं, always we will connect in parallel, जिसके cross भी potential निकालना है, measure करना है, ठीक है? So it will look like this. In this case, almost all the current will go through R2. Almost no current will flow through voltmeter because this voltmeter has a very high resistance. So it is almost acting as an insulator. यहाँ पे ये किसकी तरह act कर रहा है? Act as an insulator. And that is why what is happening here? This voltmeter is able to measure the actual value of potential across IR, across R2. So because we are adding this device in parallel with R2, that is not affecting the value of potential difference across R2. Okay, so this is your voltmeter. Anyone is having any doubt, then let me know. किसी को कोई डाउट है वोल्ट मीटर में? इफ यस यू कैन लेट मी नो. ओके किरण, ठीक है. एनीबडी एल्स? Whatever question you will be getting in a meter and voltmeter, if you know the concept that I have dealt today, you can easily crack the question. You won't be getting any difficulty. But you should try doing questions. किसी को कोई भी doubt है in voltmeter and a meter, then let me know. Nobody? Everyone clear with this? So then I have some questions, but let me check first if there is any question from voltmeter and ammeter. That we will do first. If there is, then. Okay. Let me check. Okay. No, I am not included because mostly we do this question after, I mean, after galvanometer is done. But मैंने पहले करवाया because in current we can do this, ठीक है? So no worries. I will be including tomorrow 2 or 3 questions. After that, we will be starting with the next portion. So as of now, let's start with this question. We have some time, right? We can do one question at least. चलो मैं चेक करना चाहती हूँ तुम लोगों को याद है या नहीं कॉन्सेप्ट्स. अच्छा एक चीज बताओ, रेजिस्टिविटी का फॉर्मूला कितने लोगों को याद है? किसी को याद है फॉर्मूला? तुम लोगों को एक फॉर्मूला बताया था, याद है? सेकेंड लॉ ऑफ ओम्स लॉ, जे इज इक्वल टू सिग्मा ई. सिग्मा वाज व्हाट? कंडक्टिविटी. इसका वैल्यू क्या आया था? एन ई स्क्वायर टाउ बाई एम. दिस वाज योर सिग्मा. रो विल बी, रेजिस्टिविटी विल बी हाउ मच? 1/सिग्मा. ठीक है. एम बाई एन ई स्क्वायर टाउ. Calculate it now. N is given here, number of charge carrier per unit volume. Mean free time, that is tau, is given. And you can then calculate what? Kiran, resistance के term में आप बता सकते हो. But I mean, R is equal to rho L by A दिया है मैंने. अगर R पता है, L पता है, A पता है, then you can calculate rho. लेकिन on microscopic term मैंने ये formula दिया था, if you remember. ठीक है. सो यहाँ पे तुम्हें पर यूनिट वॉल्यूम चार्ज कैरियर इज गिवन, एन का वैल्यू इज गिवन, मीन फ्री टाइम दैट इज टाउ इज गिवन. ठीक है. एंड मास ऑफ इलेक्ट्रॉन इज गिवन. चार्ज ऑफ इलेक्ट्रॉन ई यू ऑलरेडी नो, 1.6 into 10 to the power minus 90. You can put in the values, you can get the answers. So I will suggest everybody to to what, to remember all the formulas first thing, to have an idea of what you have learned throughout all these sessions. Okay? I have taken 6 class of current electricity, and you should have idea of now that what things you studied. Then a formula should be in your hand. So tomorrow in the class, we will be solving some questions first, and then if time allows, we will be starting with magnetic effect of electric current. Okay? But tomorrow we can stick to question solving. No worries. We will be doing lots of questions. So everyone stay prepared with your formula thing. Keep formula in your mind so that that will help you while doing the questions. Okay? Anyone, any doubt? Then let me know. ठीक है. तुम लोग formula please याद रख के आना. I will be uploading the full notes of this current electricity on the portal, so you can check the notes also. Anybody, any doubt? If you are calculating this, then let me know. If you are getting answer, and if you have doubt, then let me know. Yes. Anybody who calculated it? सिग्मा का वैल्यू क्या आएगा बताओ, इनका वैल्यू पुट करो 8.5 इंटू 10⁻28, सिग्मा निकाल लो क्योंकि रो क्या हो जाएगा 1/सिग्मा. So this into e square 1.6 into 1.6 into 10⁻−38. Tau is how much? 25 femto Fermi or femto. This is femtosecond. ठीक है. So femto meaning 10⁻−12. ठीक है. So this is 25 into 10⁻−12, and this divided by 9.1 into 10⁻−31. First you deal with the power. अगर आप power के साथ deal करोगे, 28 minus 38, this will -10. -10 and -1 2 will become how much? -2 2. And then that will femto 10⁻−. Yes, yes, yes. Sorry, sorry. मैंने कुछ और ले लिया. Sorry, sorry. Yes. Femto is 10⁻−15. Correct, correct. Sorry. So this is this, right? Now, if you deal with it, thank you, Lakshmi. So 28 minus 38 minus 10, this is -25 and -31. So on the up, it will go 10⁻6, right? And if you deal with digits here, digit को अगर आप deal करोगे, this will become 2.56. And this is 25. This is into 8. On the numerator, it is this, right? 25 into 8 will become how much? It will become 200. And 200 into 2, that is almost 400. So 400 by 9 into 10⁻6. So we can say 4 by 9 into almost 10⁻8. ठीक है. So it will be approximately of the range of how much? अगर आप 1/rho निकालने जाओ, 1/sigma you will do. So 9/4 into 10⁻−8, it means it is of the range of 2 into 10⁻−8. So correct answer should be what? It should be D. ठीक है. So correct option will be your D. You should remember all formulas. माइक्रोस्कोपिक लेवल पे मैंने बहुत सारी चीजें आप लोगों को बताई है. करंट बताया है, करंट डेंसिटी लिखा है, और क्या बताया था? यस, रो का वैल्यू बताया एंड हेंस ऑफ सिग्मा. सो यू शुड रिमेंबर ऑल द फॉर्मूलाज. कल के क्लास में वी विल डू मोर क्वेश्चंस. ठीक है. चलो, बाय एवरीवन, टेक केयर ऑफ योरसेल्फ. Keep doing more number of questions. Okay. थैंक यू लक्ष्मी. थैंक यू. बाय बाय. टेक केयर एंड कीप लर्निंग. ठीक है. सही से प्रैक्टिस करते रहो. किरण, बाय बाय. थैंक यू. थैंक यू. वी विल मीट टुमारो. बाय.